All right, so I'm going to show you how to model CF4 as a molecular bond. So we know this is molecular or covalent because carbon is a nonmetal and fluorine is a nonmetal. And so they're going to bear a bond using shared electrons. All right, first step is figure out how many valence electrons we have to work with. So carbon is in group 4, and so it's got 4 valence electrons. There's only 1 in this molecule, so that gives us 4 to work with. Fluorine is in group 7, and so it has 7 valence electrons, and there's 4 in this molecule, and so that gives us 28 more valence electrons to work with. So that's a total of 32 valence electrons that we need to find a home for. All right. So our central atom in this case is going to be carbon because there's only 1 of them. Carbon a lot of times is a central atom because it actually has 4 valence electrons. It can share on 4 sides and tends to do so. That's one of the reasons it can bond with so many things because it forms 4 shared bonds. All right, and we'll draw a single bond to start with for each of our atoms. Right, and so that's going to use up 2, 4, 6, 8 of our valence electrons, and we're left with 24 to place around. So carbon's happy, so we can't add any more to carbon. We can go ahead and start adding electron pairs to each of our other atoms. So it's 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, and 24. All right, if we check, notice that we've got 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8. All of our atoms are happy. So that's our finished molecule for CF4. All right, so this time we're going to draw the molecular compound that comes from our faces. It is CO2. Carbon dioxide. So we know this is a molecular or covalent compound because carbon and oxygen are both nonmetals. All right, so our first step when we're showing the bonding of nonmetals is we need to calculate our valence electrons. So carbon is in group 4. It's going to have 4 valence electrons. There's only 1 in this molecule, so we just multiply that by 1. And oxygen is in group 6 on the periodic table. And so we multiply that by 2 because there's 2 oxygens in this atom. And that gives us 12 more valence electrons. So now we've got a total of 16 valence electrons to work with. So our central atom, in the case of this molecule, is going to be carbon because there's only 1 of them. And we can just draw the oxygen on either side and connect that with a single line to show 2 shared electrons here, 2 shared electrons here. So that's going to take care of 4, but we've got 12 more electrons to place. And so here we can go ahead and do 2, 4, 6, 8, 10, and 12. So notice that our carbon's happy, our oxygen's not on either side. And so what we can do is we can take 2 of these electrons from an atom that's already happy. It's already got 8. We can use 2 of those and share them. And so we can turn that into a shared electron pair as a line, take them away from down here. Now carbon's happy, this oxygen's happy, so we got 1 more to make happy. They've only got 6 valence electrons. So we can do that 1 more time on this side. Turn this pair of electrons, this lone pair, into a shared pair. And now we've got 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8 valence electrons. And so that would be the molecule for carbon dioxide. Thanks for watching. All right, so for this challenge problem, we're going to show the molecular bond for NHO3. So notice this has 3 different elements. That actually goes beyond what you have to do in the Georgia state standards. You really just have to be able to figure out the bonds for binary compounds, or just compounds with 2 elements. But I'll show you that it can be done in the same format, even for much bigger elements. Now this one's tricky because it really will only work one way. kind of show you what I'm talking about in a second. So first step, we know that this is a covalent bond because nitrogen, oxygen, and hydrogen are all non-metals, okay? We need to figure out our number of valence electrons. So nitrogen has 5. There's only one of them. Hydrogen has 1 valence electron. There's only 1 in this molecule. And oxygen has 6 valence electrons. There's 3 in this molecule. All right, and so a little quick addition. We've got 19, 24 valence electrons to use. All right, so typically we're going to pick the element that there's only one of to be our central atom. Hydrogen's never going to be your central atom because it doesn't have 4 places for electrons to go. It only has 1 spot for 2 electrons in that shell. And so nitrogen's going to be our central atom this time. Right? And we can go ahead and draw our oxygens going around. Now, you may be tempted to put hydrogen down here. In fact, you won't be able to get the bonds to work correctly here. Remember, nitrogen is in group 5, and so it has 3 spots. It needs 3 more electrons to have a full outer shell. And so what that tends to mean with covalent bonding is it's going to have 3 shared bonds. And so what we'll do is we'll actually stick our hydrogen off of one of these oxygens. Remember, oxygen's in group 6, so it's going to tend to like to have 2 shared bonds before it has a full outer shell. All right, and so if we go ahead and count up our shared bonds, we've got 2, 4, 6, 8 valence electrons already taken care of. That's going to give us 16 to put around. Remember, hydrogen gets no more because it's already happy. All right, so we can go ahead and put 2, 4, 6, 8, 10, 12, 14, and 16. So notice that hydrogen's happy. It's got its full outer shell 2. This oxygen's happy. It's got 2, 4, 6, 8. This nitrogen's happy. It's got 2, 4, 6, 8. This oxygen's happy. It's got 2, 4, 6, 8. This oxygen is missing a lone pair, okay? But we've used all our valence electrons. So we have to turn 2 of our valence electrons into a shared pair. And so we'll go ahead and take them from one of the atoms that are connected to that oxygen, which would be this nitrogen. It's already happy. So we can take 2 of its electrons and share them. So now they count for both the nitrogen and the oxygen. And now we've got a completed diagram. So we've got 2, 4, 6, 8 for this oxygen, 2, 4, 6, 8 for nitrogen, 2, 4, 6, 8 for oxygen, 2, 4, 6, 8 for this oxygen. So that would be our completed diagram. Thanks for watching.